Hello, good afternoon, everyone. I'm audible. Just write down the chat box. Yes or no. Someone can. Okay, fine. Thank you. Can you able to see the screen? A problem fixed. Okay, so just wait for 2-3 minutes more, and then we'll start. Okay, so let us start with the problem. I think you might have gone through the earlier video. Now we'll go through the problem related to the fixed wing. Earlier we also solved the problem related to the drop cantilever. So find the friction moment for the beam loaded as shown in the figure. And the figure is like this. A point, B point, the load is acting on it. Now if we need to calculate the friction moment for this, meanwhile we should just draw the diagram as well as write down the problem. So in this problem, first of all, we just need to consider this as simply supported being subjected to external loading, and then we will remove the external loading, and only for the friction moment we have to draw the bending moment diagram. So this one is the bending moment diagram for simply supported beam. So this would be WL by 2, and this would be 38 times WL. Is also 38 times WL. Now these are all the related to SFD BMD part, which might have covered in your strength of material. So we'll be directly using that one. Now here in this problem, since this is a fixed and there would be the friction moment as MA and MB. So we have drawn first of all bending moment diagram for the simply supported beam. Considering simply supported beam, it means that suppose this is a beam, and we have just considered now that this is acting like this and have the load of W1. This is W. This is all L by 4, L by 4, and L by 4. Now in this case, your bending moment diagram will look like this one. Now the next part would be just to draw the bending moment diagram, considering that there is only fixed beam. So next condition, before the first condition, second condition is there. So you have to just consider only there is a fixed beam and there is no load. Now for this condition, what would be the bending moment diagram? So bending moment diagram is to be like this. This is going to be the plus, and now this has got to be -1. This is negative. This is MA and this is MB. And this MA and MB is to be drawn, considering this as only bending moment diagram for fixed end. So there is no load acting on it. So this is the second case. The first case, when the load is acting, and we have removed the fixed end as well as consider it as considering the first case where the load is acting, external load is acting, and there is a simply supported. While in the second case, we have just removed the load and only fixed end. So because of this, we got the two bending moment diagram. Now we can merge this bending moment diagram. So if we just merge, in this case, we will get so this is minus, and this one is plus. This is the final bending moment diagram. So this one is the final bending moment diagram. If we just merge, these two diagrams are merged in this final bending moment diagram, so we will get this one is plus and this one is minus. So we have to just indicate where is the plus and where is the minus one. And this is how we will get the final bending moment diagram. Now we need to calculate the values here. So to calculate the values, what we need to do, so first of all, we have to consider that the beam is symmetrically loaded. Since it is symmetrically loaded, so in this case, we can say that moment MA would be equal to MB. Whatever moment is there, since symmetrical beam, so we have this moment MA will be equal to MB. What is MA and MB? MA and MB will be this one. So that is equal. So in this case, we need to just calculate the M by EI diagram, that is moment upon EI diagram. So for this condition, we need to consider this MA plus MB would be equal to the both area of this first diagram and the second diagram. We need to add it. So we'll get it minus 2 into that area of the bending moment diagram divided by L. Now since MA equals to MB, so you will get MA would be equals to MB, and that is equals to minus AS divided by L. Now area we need to calculate. So here area is need to be calculated. So therefore we can write down MA, that is equals to MB, and that is equals to minus let us have this 1 by L into so this one is 3 divided by 8 WL. This is 3 divided by 8 WL, and this one is WL by 2. So we can simply consider this as triangle part. These are the triangle parts, and once we calculate the triangle part and the remaining part we will consider. So first of all, so triangle part would be half into base, that is 3 by 8 WL, half base into height. Height is going to be 1 by 4, and this is all. If you just multiply it by 2, it means that we are going to multiply for the case 1. This is the case 1, and again the same would be for this case 2. Now the remaining part would be plus WL by 2 plus 3 by 8 WL divided by 2 multiplied by L by 4. So considering this total area. So this total area, so if we just consider this as the first one, so the first, and this one is the second, considering this as the two trapezium, in that case we will get like this: WL by 2 plus 3 by WL and divided by 2 multiplied by L by 4. So this is also, this is 2, will get the first triangle, or you can consider this as the triangle area, and this is considered as trapezium. So trapezium, as a draw here. So for this condition, we got this area, and if we solve this one now, so if we just solve this, in that case, we will get this minus 2 by L into 3 times W L square. This is L, sorry. So W L square divided by 64 plus 7 into WL square divided by 64, and this will give you final value. Therefore MA would be equals to MB would be equals to, if we solve this, minus 5 by 16 WL. This is what we needed. Okay. So at what time is your next lecture? Is it at 4? You said on the chat box. Someone. Hello. Next lecture because can we go in for the next problem? We'll go for the problem. Find the fixed element and plot the SFD and BMD for the beam as shown in the figure. So the loading is given in the problem. 3600 Newton, 900 Newton, 400, 4000 Newton, 3600 Newton at the distance of 1 meter, 1 meter, 1 meter, then 2 meter, and then lastly 1 meter. So this is how the problem is, and we just need to solve this for calculation of SFD and as well as the BMD. Then this is the friction friction link. So again, as I said, this will be going for step-by-step process. So here what you just need to do, since this is the Zoom one, or you have to just use this meeting now and again rejoin it within 1 or 2 minutes. This will end automatically.